Part C, the full-scale ray diagram below is incomplete. Complete the diagram to show the formation of the image. So what you can see here is already there's a line drawn from the object. It crosses the principal axis here, or the line which represents the lens actually, and then it's drawn down through the principal axis. Now you know that it always crosses the principal axis at the focal point. So I'm going to mark an F here, and therefore I know that that's 1, 2, 3, 4, 5, 6 centimeters out here. So 1, 2, 3, 4, 5, 6. There's my focal point on the other side. Now what that means is that the object is between the focal point and the centre of curvature of the lens. So therefore that means that this is going to be a virtual image. So we need two rays. We need one continued, and that one that's continued should be a dotted line like that. And the reason is because we know it's a virtual image, and so we always draw a virtual image as dotted lines. And then the other line that I would put in here, the other ray, is a line which goes from the top of the object down through the centre of the lens, and then we have to continue it just above. And so there's your continued line above, and again it's dotted. And then our new image here is upright this time. So you can see a ray that passes through the top of the object also passes through the top of the image, and this therefore, since it's like that, then that means that it's also virtual. So to get your marks there, you've only 3 marks going. So there's a mark for this ray, a mark for this one, and one for your image. And I'm just going to write I down here. Which two of the following words best describe the image? And again, when you look at it, you can see that we've decided it is virtual and that it is upright or erect. And so we're going to write erect and virtual. Mark the position of the principal focus on the diagram with the letter F. Now I've already got them marked. F and F there, or the focal point as we often call it. What is the focal length of the converging lens? So you have to measure that distance, and we've already decided that it's 6 centimeters. The question, however, asks you to put in the focal length in millimeters, so just be careful about that. So 6 centimeters is actually 60 millimeters. What is the name given to a converging lens when used to produce an image of this type, of the type being shown? And the answer is, of course, it's been used as a magnifying glass or a magnifier or something similar to that. So it's been used to make the image look bigger. Part D of the question. The diagram below shows a ray of light passing from water into air. On the diagram, draw a ray from O, leaving the water with 0 refraction. Label this ray X. Now you've got several rays to draw, and I think the confusing thing about this is that what you have to do is draw starting from O but going from different points, and it's really a little bit off-putting. So leaving the water with a 0 angle of refraction. Now if it has a 0 angle of refraction, that means that if that's your normal at the surface there, that means it's going along the normal. And the only time that that will happen is if the ray is just passing straight through the water, straight into the air. In other words, it's not refracted at all. So there's your first ray there, and this is X. Alright, second one, leaving the water with an angle of refraction of 90 degrees. And if that's the case, and we look at this little diagram again, there must be a right angle there. And so that's going to happen whenever your ray is going from here at a slightly larger angle, because we know it should be, at water, it should be roughly, well, it's 40 to 48 degrees, about 48 degrees. The critical angle for water. You wouldn't really be expected to know that, but it is a bigger angle than if we drew a normal in here. So I've just drawn a ray, I've drawn an angle in here, an angle of incidence, and then I'm going to draw an angle of refraction of 90 degrees. There's your 90 degrees there, and you have to label it Y. Third one, undergoing total internal reflection, label this ray Z. And so what you have to do, and I'll use red again, is make sure that wherever you draw your normal, that your angle is bigger than this. So if we move our normal along again and draw a ray here, so that's your ingoing ray from naught, and then outgoing has to be roughly the same angle, which is fairly large there, say about there. You could use a protractor to do this properly, but they will give you that if it looks fairly good. So that I and that R have to be roughly the same to obey the law of reflection, and label it Z. For the appropriate ray, mark on the diagram the critical angle using the letter C. So that happens, the critical angle happens whenever the angle of refraction is 90 degrees, and that must be, I'll do it with a purple again, that must be in there. So that's a fairly complicated looking diagram there, as you can see, and it was quite a lot to actually draw on one diagram. State two uses of total internal reflection. And so one use would be optical fibres in communications. You could also say for sending, for use in the, to send signals for the internet. But don't just write internet, because they won't give that to you. You have to be a little bit more specific than that. It's also used in optical fibres in medicine, or in the endoscope, or in keyhole surgery. Endoscope or keyhole surgery. So make sure that you explain what it's used for, and don't just give one word answer, which could be ambiguous and which an examiner may or may not mark correct.